Okay, so this webinar is was organized within the ILIAD project. And we are focusing today on the two next days on citizen science, which is a really important part of the ILIAD project. And we wanted to do these webinars for the project, for the ILIAD partners, but also open to the public so we can share our work and our ideas with your ideas as well. So make sure to tell us what you think and so on. These webinars are going to be recorded. The presentation, we record them because we want to make the presentations available to the public afterwards. But the discussions won't be published. So feel free to say anything during the discussion and take part in the discussions. And you will also be able to see again the presentations of the different speakers afterwards. So first of all, I'm going to make a short introduction of the ILIAD project, and then we'll start with the presentation themselves. Stephen Parkinson is going to give a brief introduction to citizen science. Then Georgios Sylaios will explain us how we can scrap data from social media and to transform this data into citizen science. And then at last, Miroslav Markov will give us an example of a use case where citizen science was applied. It's within the Varna harbour, and he will tell us about that. And after that, we will have time for discussion. So I hope we will have a lot of things to share together. So first of all, let me present briefly myself. My name is Laudy. I am an expert in artificial intelligence, and I work for Thales Research and Technology Lab in France. My first interests were in human-machine interaction, and then I just switched and went to information modeling, information fusion, and semantic information fusion. I'm involved in the information fusion community as a whole, and I was recently elected at the board of directors of the ISIF, which is the International Society for Information Fusion. And I've worked in many domains, let's say, and mostly with information coming from social media and a bit from citizen science as well. So let me introduce the ILIAD project very quickly. The aim of ILIAD is to provide a digital twin of the ocean as an interactive framework that is based on technologies that are compatible with this destination Earth. That includes ocean simulators based on high-resolution numerical ocean models, and also already available observation data, as well as, on the other side, analysis toolboxes that enable to configure the simulators and also run some what-if scenarios and see what we can predict and do about the ocean and, well, manage all that, monitor all that. ILIAD in a nutshell, we are developing interoperable digital twins. We are connecting existing ocean data infrastructures. And what we want to do is enhance this infrastructure with new observation, new technologies, and among all, also citizen science, which is not already very represented in these existing infrastructures. We also want to create an open marketplace accessible for all providers and users. And this will enable users to, well, get any, let's say, analysis functions or data from this digital twin of the ocean, and use this analysis tool, these prediction tools, in order to make their business. And we also provide solutions that address future social challenges. And we do that by building a broad user community uh, through citizen science engagement, of course, and also other users. But today we are going to talk a lot about citizen science engagement and how we engage these users. And also we provide this solution by supporting the communities that needs access to ocean data and analysis of this ocean data. We want to make sure that you know that ILIAD is not one digital twin of the ocean. It's like several digital twins that we want to collaborate. We want them to be interoperable and so on. It's like having several small digital twins, because a huge one wouldn't be very efficient. And we have that for many applications or domains. We have these wind farm capacities, some about energy, some used for coastal sediment transport, plastic pollution, oil spills. Also, insurance companies are interested in such data for people forecasting jellyfish swarms, harbour safety, and all of these fisheries, of course, ballast water monitoring, aquaculture, and so on. So this ILIAD is a really broad project where we have a lot of different activities coming into the place. Well, here you have a few numbers about ILIAD. What I want you to remember is that the project started like 1 year ago in February 2022, and it's a 3 years project, so it will end in January 2025. We are a lot of partners, a lot of different partners, which makes it a really interesting project. We are 58 partners, and well, this is ILIAD. And so first, our first presentation will be a brief introduction to what is citizen science, and this presentation will be given by Stephen Parkinson. So Parky is a member of the innovation team at Earthwatch, and he works on the MICS project. And previously, he was coordinating a water quality citizen science project called Freshwater Watch. So I'll let the floor to Parky.
Thank you very much for the introduction. I'll just share my screen now.
Yeah.
Perfect. So this webinar on citizen science for digital twins of the ocean was originally also aimed at people who might be unfamiliar with citizen science, but kind of interested in digital twins from a more technical perspective. And so I've been asked to give a brief introduction on citizen science today, which is actually quite a challenge, because for those of you who are familiar with citizen science, you'll know that it can be a very diverse approach and can look very different in different projects. And there's a lot of interesting things that could be said, and I definitely won't have time to say them all, but I'll do my best to give an overview, and hopefully we'll have more of a chance to explore the topic in depth in the webinar over the next 3 days. So I'll start with a definition. So citizen science is scientific work undertaken by members of the general public, often in collaboration with or under the direction of professional scientists and scientific institutions. This isn't a perfect definition, but it captures some of the kind of core aspects of citizen science. Firstly, that there's some element of research taking place, and that members of the general public are actively engaged in that research. Now, what the general public means can vary from project to project, but typically it's some kind of non-professional, so someone who isn't a professional scientist who's actively engaged in this research, and is working in collaboration with professional scientists. And again, this relationship with professional scientists can vary from project to project as to who is leading the project and who takes what role in the project, such that there are even citizen science projects where there is no collaboration with professional scientists and it's purely run by citizens. But yes, this definition starts to give a sense of the kind of core elements of citizen science. And I've also, to kind of bring this definition to life, I've chosen 4 contrasting examples of marine citizen science projects. And we will hear also even more diverse examples over the course of these 3 webinars as well. But so the first example to consider is you might have tourists on a whale watching tour who, when they spot a whale, they take a photo, they identify the species, and they upload this observation on a biodiversity monitoring app, which then gets uploaded into a biodiversity database. So they kind of contribute to biodiversity monitoring. Equally, you could have a case where volunteers help to classify satellite images for features which are not very easy to detect automatically. So there's a whole kind of category of citizen science projects, of online citizen science projects, where people volunteer from their computer at home to normally do some kind of data analysis or image classification. And there's an example here of kelp forests, which have a particular spectral signature, but one which isn't particularly easy to automate the detection of, because it's easy to mistake for other ocean features. But us as humans are quite good at spotting the pattern of where kelp forests are. So there are thousands of volunteers who regularly kind of sort of highlight areas on satellite imagery where there are kelp forests to help the analysis of that imagery, and help kind of research into tracking where there are kelp forests and how their distribution is changing. Another example, citizen science could be fishers who are asked by researchers to add a sensor on their boat or collect a water sample whilst out fishing. So again, this gives a sense of how that definition of the general public can change from project to project. You know, this is not necessarily all members of the public who are able to take part, but in this case, fishers, either like professional fishers or sort of amateur fishers, but people who have a boat and are going out into the ocean. And then they might be engaged by scientists to help collect water samples for their research. And a final example here, you could have community groups who really care about their local environment, going out to their local beach and cleaning litter from the beach. And whilst they're doing so, also collecting data on the different types of plastic pollution that they find there. And in this case, yeah, it might be much more sort of community-driven, action-driven, rather than necessarily coordinated by a scientist and such, but there's still an element of research being taken place or data being collected to sort of produce information about sources and sources of plastic pollution. So those are just 4 kind of diverse examples of citizen science, just to give a sense of what citizen science can look like. And another way to highlight the diversity of citizen science is to consider what a citizen scientist can do in a project. And normally people just think of data collection. This is the typical role of citizens in these types of projects. But they can also be much more involved in the project, for example, in analyzing the data, in recruiting or engaging other participants, in designing even the technology being used to carry out samples in the project, for example, making low-cost sensors in a makerspace, in arranging project events, or even in identifying the research question for the project, or even in setting up the project in the first place. And there's often a trade-off between the number of people engaged and their level of involvement. And to add to that, even like a more passive form of participation, for example, some kind of data scraping from social media, in which it's possible to collect data from millions of people, but they have almost no involvement with the project, versus something like citizens actively engaged in collecting data for the project, where it's still possible to involve lots of participants, but maybe not as many as from data scraping, versus then something as in-depth as identifying a research question. It's just likely that that will require some level of detailed discussion that's only really possible with a smaller number of participants. So that's just another element of citizen science to consider, and again demonstrates the different roles that citizen scientists can play in different projects. So citizen science is currently a rapidly growing field, and you might have heard citizen science mentioned more frequently, or seen more citizen science projects. And if you haven't been involved with a citizen science project before, you might be wondering why people bother. It's sometimes sold as free labor or an opportunity to collect large amounts of data at a low cost. And it's true that the data from citizen science is a big part of its value, but the aspect of low cost is often not the case, because engaging participants in the project requires a lot of time and effort to kind of train them or to engage them properly in project activities. But there are still benefits to the project, but they might not be just about the data. And at its best, citizen science is really about meeting needs. And that's usually some mixture of scientific needs, which might not be formal academic needs, but some kind of question which needs research to provide information for, and also some kind of societal need that's being met, something that will give a reason for citizens to be interested in getting involved and spending their time and effort on the project. And the balance of scientific and societal needs might be different in each project. In some, it might be more of a scientific focus or more of a social focus, but almost every citizen science project has some aspect of both. Now, as I said, I really don't have time today to go into everything there is to say about citizen science, but I thought for those of you who are new to the area, if you're interested, it would be helpful to highlight some resources that are kind of good. So if you're interested in reading more, you can go and explore. And the first thing I just want to highlight are these things called the 10 Principles of Citizen Science, which were developed through the European Citizen Science Association, and which really help to define how a citizen science project should be designed, and what characteristics a citizen science project should have. There's also a website called eucitizen.science. The URL is on the slide there. And this is a kind of repository which contains loads of example citizen science projects, which you could look at and kind of find inspiration from. But it also has loads of resources and training materials to help people to design and run citizen science projects. And it has tools for all sorts of things, and for all sorts of aspects of citizen science, one of which is an example from the MIX project, which I've worked on, which helps projects to measure the impacts of citizen science and to design a project for impact. And I've put up here an example of an impact report from MIX. But if this is something that interests you, then make sure to also come to our webinar tomorrow, where we'll also go into more detail on the impacts of citizen science and the opportunities and challenges there. But the point I'm trying to make is there's loads of knowledge that exists now on how best to run a citizen science project. There's lots of expertise there. So if you're ever considering running a citizen science project or including some aspect of citizen science in a project, I really recommend that you find an experienced partner to work with. There are lots of people out there who now have experience with citizen science. And yeah, it would be probably to everyone's benefit if you worked with them to design your project so you can kind of incorporate these lessons learned from previous efforts. I thought I would just finish by reflecting on what citizen science could mean in the context of a digital twin of the ocean, which is the context of ILIAD. And the first thing to say is, yes, citizen science can provide data. I mean, digital twins of the ocean are inherently about data, and citizen science might help to fill data gaps or help with validation of models, but citizen science can also increase the societal relevance of the information produced. And the digital twins and involving citizens with digital twins might help citizens to make decisions or to change their perspective and ultimately to change their behavior. It might give citizens a tool to have evidence to kind of lobby organizations to go to policymakers and businesses and ask them for change. It might give citizens the means to express their needs, to sort of be able to say what their vision for the future of the ocean would look like. And ultimately, in all of this, to give training and learning experiences which change citizens' knowledge and attitudes and behavior towards their local environment. And I think this goes back to what I was saying before, that citizen science is about meeting needs. And in the case of a digital twin of the ocean, it can help to meet the scientific needs for sure, that need for data. But there's also this potential here for citizen science to help to identify and to meet societal needs for a digital twin of the ocean, which I think is a very important aspect. So I think that's all I have time for today. So thank you very much for listening. And I look forward to hearing what the other presenters have to say, and I'll be happy to answer any questions at the end.
Okay, thank you, Barky. Yeah. So our next presentation will be how to use data from social media, which is not purely citizen science in a way, but how to transform that into citizen science. And this will be given by Professor Georgios Sylaios. Georgios is a food professor at the Democritus University of Thrace. In the Department of Environmental Engineering in Greece. He's head of the Laboratory of Ecological Engineering and Technology, and he was since the beginning a physical oceanographer, so with a very long experience in that field also, so he knows well about all these questions about oceanography. He's also been coordinating big projects such as the Odyssea project that came before ILIAD and is now part of ILIAD, of course. His publication list includes well, almost 300 scientific publications, and he will tell us now about using social media for science. So I'll leave you the floor, Georgios.
Thank you, Claire. Thank you very much for this introduction. So I will share my screen, and I will. So I'm going to present you today a presentation which is relevant to how the data from social media could be used for the environmental citizen science data pools. As Claire explained, I'm not really an expert on citizen science, but in my lab we have long experience on developing algorithms, and this is what we are doing. We are trying to transform through data scrapping the social media data into something useful for oceanographers and for environmental scientists. So social media offer the capacity really for users to generate big data. They interact with the various platforms, and people really upload their views through, in the case of Twitter, through tweets. And then this creates what is called user-generated big data databases, which can be analyzed through big data analytical techniques like machine learning, etc. And this is what we have done. We have collected posts from the Twitter in order to understand the patterns and the trends, and we examined a few characteristics of these tweets. So the gender, the location of the person who was tweeting, the topics that were discussed and how these are relevant to climate change in our case, the stance, the sediment, and the level of aggressiveness. So these are the characteristics that we tried really to identify through the Twitter posts. So as I said, we created the biggest, for the moment at least, climate change Twitter database. It is a data set which consists of more than 15 million tweets, in which people from all over the world speak about climate change and global warming. This climate change database covers the period from 2006 until 2019. It's in English only. We have published the database and the dataset in a paper in Elsevier, Expert System with Applications by Frosinidis et al. In 2022. And for each tweet, as I said, we extracted the geolocation, the temperature deviation at the time and the place the tweet was written. So since we know the exact coordinates of the location, we were able really to go to historical temperature databases and see what is the current deviation against the mean temperature this particular area has, the gender of the person who was tweeting, the stance, the sediment in terms of climate change, and the topic of the discussion. The data set is also accompanied by environmental disaster events. So we try to see whether people after an environmental disaster event are tweeting more, and what are the topics they discuss, and what is the stance against climate change, and if they consider that this climate change is something which is triggered by humans. We cover, as I said, a 13-year period. And in terms of data preprocessing, this is a very lengthy procedure. We hydrated the data, meaning that we linked the user's ID with the Twitter post content. Then we filter the data in order to use certain hashtags which contained keywords which were relevant to climate change and global warming. There is a database which gives us a series of keywords that we can use in order to identify which are the more appropriate for this job. Then the geolocation, we use the user geolocation, and in case this was not available, we use the Twitter metadata for each tweet. So we're able, through an indirect process, to geolocate the person who was tweeting. Then we linked the names of the person who was using the Twitter with a GeoNames database in order to identify the gender. We use the machine learning algorithm in order to identify which is the gender hidden behind the name. And then we classify the stance. The stance was categorized in 3 classes: the believers, the deniers, and the neutrals. And then we use the classification score from -1 to +1 in order to understand and to really mark the sediment. This is an unsupervised machine learning algorithm that gives us the result of this sediment. And the aggressiveness level was, again, whether we have tweets that are offensive or non-offensive. So you see here a sample of the database that we created. For example, on the left-hand side, you see the time, the date, the identification number, the longitude, latitude, the topic discussed, the sediment score, the stance, whether it's neutral, believer, or denier, the gender, and then the temperature, the deviation of the temperature, and whether this tweet was aggressive or not. Here you see which are the main websites that people really have a tendency to use for their, or to be motivated to use for their tweets when they discuss issues relevant to climate change. So, for example, you see that most of the tweets, almost everything, is relevant to Twitter posts from Guardian, the Washington Post, New York Times, BBC, and CNN, etc. And then here you see the geolocation of the tweets with the black dots. You see that we have a lot of tweets from the United States, some tweets a bit sparse from the Southern America, Africa, a lot of tweets in Europe, and we don't have a lot of, almost nothing from China, of course. Of course, there is a bias as a result of that, I have to say. Here you see a temporal analysis of the tweets. For example, the number of tweets which are relevant to climate change over the years, which is rising from 2014, 2013 until today. Then there is a drop in 2019, which is the month which contains the highest number of tweets. And you see that May and December are the months with a lot of tweets. This is 2.5 million tweets per month, which is day of the week. People are tweeting about climate change and global warming. So you see most people are tweeting on the working days, and then over the weekend they are not really very active. And what is the time of the day? And you see here that most of the people respond to climate change and discuss about it at 3 or 4 o'clock in the afternoon, which is if someone looks at the thermal cycle, will understand that these are the most hot hours of the day, especially in the summer. What sort of keywords people use when they tweet about climate change? The believers use this type of words that you see over here: believe in climate change, real, to believe, etc. While the deniers use unigrams and bigrams, as we say in this language. So unigrams are if you are using only one word, or bigram if you are using a set of words, 2 words, in order to make a statement. We found that the climate change believers are about 10 times more than the deniers, so 71% versus 7.4%, 7.5%, while the rest 20.95% are considered as neutral. Climate change female believers are 3% higher than the male climate change believers, while climate change female deniers are by 3% lower than the males. Female believers are more sensitive to extreme weather events, so whenever we had an extreme weather events in their area, they tended to tweet in a positive manner towards global warming. In terms of aggressiveness, believers have an average score of 0.27 aggressiveness score, as I said, while deniers had a 0.42 and neutrals a 0.28 score. Deniers are more present in Canada, United States, Cuba, South Africa, Japan, Eastern China, Australia, and Brazil. In Europe, India, and Central Africa, we have low denier to believer ratio. This is what we, in fact, developed a ratio between deniers and the believers, and we use this ratio in order to understand the patterns hidden in this database. This is the deniers to believers ratio with a 5 degrees squares over the globe, and you can see with the red colors the high values of deniers to believer ratio, while with the blue colors the low ratios. And we, of course, need at least 20 deniers in order to have a result in this 5 by 5 degrees grid. This is the correlation between the denier to believer ratio and the deviation of temperature from the mean value of temperature in the geolocation the tweet was carried out. So you see that there is not a real pattern here, but if you see after 2013 and 2014, when the temperature deviation increases in their geolocation that people are tweeting, the deniers to believers ratio decreases. So there is a negative correlation of 0.53, which gives us an understanding how people really perceive climate change and global warming. Here you see a histogram which shows the number of tweets per temperature deviation bin. And this line here gives the change in the deniers to believers ratio. So what we understand from this diagram is that when we have extremely low temperatures, where below minus 3.8 degrees, then climate change deniers are much more present in the social media than they usually are. Deniers to believers ratio decrease as the temperature approaches normal levels and reaches its lower value at temperatures between minus 0.2 degrees and plus 4.1 degree. When extremely high temperatures are experienced, deniers rise, but much less. This indicates that people connect climate change with the warm temperatures than the extremely cold or very cold temperatures. The sentiment, here you see again the bins of the deviation of average temperature with the sentiment analysis, the mean sentiment score. Again, the right hand axis shows that the sentiment is negative until the temperature deviation of minus 2.9 degrees is reached. Deviations from the historic temperature are positively correlated with the sentiment until plus 0.6 degrees. And from there, it stays steadily positive. This means that when temperatures are colder than the historic average, people tweet negatively about climate change, as I said earlier. While when temperatures are warmer than the historic average, people tweet positively about climate change, despite the fact that rising temperatures are an effect of climate change. Why we are doing all this? We are doing all this because we wanted really to test our algorithms. We participate in ILIAD, as Claire explained, and we want to use citizen science through social media and test whether it's feasible to use it in a digital twin of the ocean. Here we have a test case for Thracian Sea. Thracian Sea is the area of the northest part of the North Aegean Sea. As over here is Turkey, the Dardanelles, and the outflux of Black Sea water in the North Aegean Sea. And we have a lot of models which are run operationally, and we have done this set of models. We have implemented it in the lab through the Odyssea project. So we have the hydrodynamic model, with a resolution of 1 by 1 kilometers, the wave model, and the water quality model, which considers also the outflux of the various rivers that we have in the area. What we also added now is the oil spill model, which is able to consider to take all this information from the other models and run together with the forecasts of the winds, the the potential transport of oil spill in the marine environment. What we don't have is how we are going to trigger these models. So what we are doing is that we develop algorithms in order to scan on a daily basis the satellite images from Sentinel-1, the SAR Sentinel-1 images, and based on the spectral signature of oil, to be able to identify the presence of oil spills. In parallel, and because Sentinel-1 is not always crossing the area, we want also to scan the social media. So we, in parallel, will run another algorithm to scan whether there are posts, any reports which are relevant to oil spills. And based on these databases, this is what we call the event identification package. which will trigger all these models and will effectively give us an understanding of the location and the presence of an oil spill in the sea. We also develop another algorithm. We just finished the publication. It will appear soon on machine learning models for the forecast of localized wind speed and direction. So it will really speed up the processes, because in the past we were using downscale meteorological models. Now we will substitute that with the machine learning algorithms. And we are doing this in order to alarm the authorities and to aid them in their response and the mitigation of these events. And then we intend again to use this algorithm of the citizen science and social media evaluation in order to see what the response of people in the cleanup operations and the mitigation of the authorities. So this is a package, what we call the digital twin of an oil spill. And we are currently working on an oil spill event which happened in 2021, in August 2021, in Syria. There was an accident from an oil refinery from Syria, and oil was released in the Levantine, and this oil spill moved towards Cyprus and from there to Turkey. The oceanographic community, the event happened on the 21st of August, and the oceanographic community responded with the first outputs of the results of the oil spill 5 days later. So this is what we are trying to improve, to produce all the tools and the algorithms to be ready to respond as soon as possible based on data which are provided openly and freely available through various platforms. As a conclusion, I would say that social media could offer a data pool for environmental scientists. Twitter allows, for the moment at least, free access to the tweets and could be extracted. From there, we can extract and analyze in terms of geolocation and terms and gender the posts, the Twitter posts. Sediment analysis could be applied on text mining results from Twitter posts. The stance, sediment, aggressiveness could be rated to perceive public perceptions on certain issues. I just explained the climate change case, but we can apply on any environmental issue. And secondary data like mean temperature, temperature deviations, extreme events could also be merged to the above dataset for a better understanding of what is happening when the report is uploaded on the media. So thank you very much.
Thank you, Georgios. So our next presentation will be on the use of citizen science for the port of Varna. And it's going to be given, you see my screen now? Sorry. Yeah, I suppose so. So the talk will be given by Miroslav Markov, who is a member of the Artificial Intelligence Laboratory at the Technical University of Varna. Is currently an assistant professor at the Department of Software and Internet Technologies at this university, and is mostly interested in including artificial intelligence and intelligence human-machine interface, and how to include all these technologies in real world and real world applications. And he will talk about to us about how to enhance the Varna port safety thanks to citizen science.
Thank you, Claire. I would like now to share my screen. Just a second. So I would like to present the activities we have done so far in Varna with regard to the citizen science as a part of our participation in the project ILIAD. So these are my details, and I will start by a few words regarding the overall concept of the Varna harbour safety pilot, which has two main goals. You can see here it covers the area of Varna Bay and also the channels that connect Varna Bay with the lake of Varna and the lake of Beloslav, where are situated the big part of the terminals of the port of Varna. We collect signals from different sensors, and how this sorry and how the citizen science activities contribute to this pilot. I will in the next slides. So the main goals of the citizen science activities we formulated as three focuses, three main activities. The first one, research, understanding and awareness regarding the role and the needs of the civil society. The second one, the promotion of opportunities and ways for active participation of society in solving problems. And the last one, creation of tools facilitating and stimulating the proactive behavior of the citizens. So we started with the creation of a Facebook page which we promoted through different channels, and we use it for promotion of our activities. Afterwards, we elaborated a survey which with the idea to find what is the degree of information through the citizens with regard to the factors for pollution of the sea, and also their readiness to participate in such activities. Then we organized a seminar in which we met the stakeholders, most of the stakeholders which participate in the face of Varna Port Pilot Station, port infrastructure employees, sailors, captains, fishermen, and also citizens who love the sea and value the sea. And we were happy to learn what are their opinions regarding the sea environment. And then on the base of all these opinions, we started to develop a web app in order to collect data from citizens, and this data to be this data to be provided to, on the first place, the pilot of Varna, on the second place, different research institutions, scientific institutions, and on the third place, to be used by the citizens through the application. We decided to make a web application with the idea users through different devices, computers, phones, tablets, or anything else to be able to access the application and to contribute for the collection of the data. And these are several screenshots from the application. Here on the left-hand side, you can see the welcome screen of the application. There are several categories. Here we have included jellyfish category in order to be in compliance with our colleagues from University of Haifa who deal with jellyfish. And also there are categories like atypical events, meteorological parameters, pollutions, and other problems that do not cover the rest of the categories. All the reports are shown here on the map, and each one of the visitors can check what has happened in the area of Varna Bay in the last 24 hours. And each one of these pins can be clicked, and it shows the actual report, all the information regarding the import inside. Of course, there are screens like this: sign up, sign in, and the option for creation of account. On the next slide, you can see the welcome screen for the registered users. Besides that, it is already personalized. The users have the option to give a report here with these buttons for each one of the categories. And again, they can observe the history of reports here on the map. On the right-hand side, you can see some examples of such reports. Here we have heavy rain on the beach and also jellyfish, which have been reported. This is the screen of how you can post a report in the page. There's a geolocation of the user who makes the report, and he can leave a description and also add an image here, which will be visible for the rest of the users. And on the next slide, this is the admin panel, in which on the left-hand side, the administrator of the app can filter all the reports, for example, in an interval of time, and also by category, in order to visualize part of the reports. And similarly, the users can, each one of the users can see their history of reports. Here we have some examples with drop container into the water, or here even a bomb. And also in the category of meteorological events, the heavy rain on the beach. There is a screen also for fast connection to some organizations. The first one, the call for emergency, and also here we have added the Fisheries and Aquaculture Executive Agency, but there will be organizations that will be added in addition. Again, this is the current version. It is still not deployed, not hosted, but will be probably in the next, in the upcoming weeks or month. This is the About Us screen with some motivational statement here for our mission. And actually that was the application. And in parallel with the web application, we also organized series of lectures in order to gather people who love the sea, who want to participate somehow for this mission. And this is one of the lecture, Underwater World of Black Sea, and also one regarding the biodiversity of the Black Sea. They were very interesting, and we gathered really number of people and promoted our ideas, promoted the application and what we have done so far with regard to the citizen science. And the last one was the hackathon that we organized, smart technologies for cleaning and preserving the marine ecosystem. We gathered young people who divided into 4 teams. They chose different challenges, and they were really very enthusiastic and motivated with desire to give their opinions and to search for some solutions regarding the environment, its protection and conservation. So I think that's all from me. Thank you so much